going to talk about, we're going to talk a lot about polynomials. As you can see in chapter 4, that's basically, and it talks about polynomial expressions versus equations. Anyone know what the difference between the expression and an equation is? Yeah, basically, an equation has that equal sign, which means you have a left side and you have a right side. And we're going to learn what you can do when you have an equation, which is, to be honest, basically anything. In an equation, you can do whatever you want to it as long as you do it to the other side. And you do it fairly. Like, if I wanted to times one side by 100, can I do that? Yeah, as long as I do what? Times the other side. Now, I have to look at that and I go, is that really beneficial to what I'm trying to do? But basically, I really want you guys to understand, you can do anything to an equation. You just have to do it fairly to the other side. You have to make sure sometimes when you distribute the correct way. But that's the cool thing about equations. You can basically manipulate the crap out of them. Expressions, there's no left side. There's no right side. So I can't keep it balanced. So I don't have as much freedom there. But I still do have freedoms with expressions. And that's what we're going to talk about towards the end. Right now, we're just going to be talking about this. Basically, big thing today is the average rate of change. We're going to look at graphs, make sure we understand them. We might go over some words from chapter 3 just to make sure we're still up to par with those guys. So, here we go. What is this graph of? Okay, talk, but what is the graph? Throw out all that. Throw out no mathematical terms right now. What is this graph of? Okay. And what kind of company is that? It's a video game company. So basically, layman's terms, straight up, here's what I have. I've got a new company, it's a video game company, and I've got how much time and how much money they made over that period of time. You with me? So we're going to look at some stuff. If I look at this, and basically I might have you do some of this for homework just to see how we do. I'm going to try to, you guys would love this, try to get you doing more. It seems like that's the consensus on why we're not doing so well. It seems like we get a lot of stuff together in class, but then when we go to show it on the test, some of us aren't. Unless I physically say, you have to do this for homework, you guys aren't to the maturity level of just going on and studying stuff on your own, it seems like. So I'm going to have to force you by giving you a little more homework, it sounds like. So here we go. The chief executive officer anxiously meets with her accountant. Where do you think that would be happening on this timeline? Where do you think that she's going to be meeting with her going, I think we're in trouble? Where do you think that's going to happen? Probably. Hopefully, she's not doing it here. Because what? She waited a long time before he or she cared for their company. Once they start seeing this downward trend, right in here, what should they probably be doing? They're probably should be meeting with that person going, hey, we need to figure some stuff out because things were going good and now they're not going so good. So I would say somewhere right in here is probably where the A event happens. Follow me? All right. The highly anticipated game Rage of Destructive Fury 2 is released. Where do you think that happens? Normally, right? Like if you ever you ever seen Busch Gardens, it seems like their attendance starts falling down, and then all of a sudden they do what? New coaster, boom! It's packed for the day. Can't get on that ride. It's like 4-hour wait, and they release that new coaster. Attendance, probably profits start spiking again. Yes? So that probably happened right about here. It's probably where a B event would probably take place. If it's highly anticipated, that means that people are gonna flock to there. They're gonna pay a lot of money, which means I can start making more. The company opened its door for business for the first time. Where is that gonna happen? probably is going to happen right here. Right there. Because that would be, for time, what were we talking about? How many months if they open the door for the first time? It would be 0 months. Which, so I'd be 0 on my X, which means I'd be on my Y axis. Are you with me? So that would be event C. And what I want you to do is I want you to just go through the rest of this. So you're going to do this one. Now this one, be careful. Be careful of on this one. Why? What does it mean to break even? Say that again. That would be profit. That would be profit. As long as I'm making more money than I'm spending, I got gains. That means I'm making money. What does it mean to break even? It means you didn't make money, but you didn't lose money. Okay? So I'm at 0. Is that how a company can run, by the way? Is by just breaking even? No. They can't run like that. They've got to make profits because profits are really going to someone's salary. Does that make sense? That's the owner. Basically, the owner of the company is only going to be able to feed their family if they're making profits. Nobody in business is out to employ other people, which means give them money, give people a service, and get nothing in return. That's not a good business model. They wouldn't be able to feed their own family. Okay? So breaking even, where would that happen? Right here, and right here. Because what would my X have to be for this one? That means when I'm breaking even, that means my X, I'm sorry, not my X, my Y, because Y is my profit, my Y is 0. What do we also call those things? Oh, this is when I'm reviewing last chapter. X-intercepts and roots. Okay, those are going to be those kind of things. So you are going to do F, you're going to do G, you're going to do H, we can even have you to talk about that. This right here, when you do this one, I want you to think chapter 3-ish. And I'm not going to write this down. I want you to write it down, but we'll talk about it to give you some juices flowing for this. First off, I look at this and I go, could a cubic be used to represent this? How many roots can a cubic have? That means it can have 3 intercepts. Well, I look at this guy and I go, 1, 2, 3. Okay, yeah. We're good there, right? Doesn't have too many. Okay, what are these guys called? Extremas. Can a cubic have 2 extremas?
Yes.
Okay, that's good. That's good so far, yes. What was the end behavior? And then what? Does that work well for a cubic function so far?
Yes.
So do you see how I could describe saying, yes, I think a cubic could do this, and here are the reasons why. And I talk about extremas, roots, how I talk about its end behavior. I can even throw in, and you know what? I think my A value would actually be what? Positive, because it starts down and it ends up. This is all stuff that we've learned from chapter 3 that we can relate to here. Following me? Good. All right. Next one. One thing that we do, and all of us do this, to be honest, when you first look at this, where do your eyes automatically go? To me, my eyes automatically go right here, and they focus in on this section. And I almost start answering questions before I've done something really, really, really important. When I focus my eyes on this, what have I left off? these guys right here, which are extremely important. Because now when I go, if you would have read this, to be honest, and I did it myself, so I'm not saying anything bad about what you probably did. Most of us would probably look at this graph, we'd actually probably skip over it, and we go right to this question right here and start reading it. We go, determine, use the graph to estimate when they achieved each profit, then explain how you determine your estimation. 800,000. You look here and you go and you're like, wait, it only goes to 800. Well, that's because we left off a vital part of this information. Over here, profits are in what? Thousands. So actually, this 800 right here actually represents 800,000. Are you following me? So those side pieces of the graph are extremely important. So 800,000. The other thing to look at this, do you see this graph? What does this say right here? This is just in years. What were we talking about? This is the same company, by the way. I know this is the same model that we did just a minute ago. But now, how did they change something? Time is now in time of, whereas before it was in time of months. With me? Okay. What is this? One what? 1 year. What is this, though? You need to be careful when we're counting. This book loves to count by different numbers. So you have to make sure that each one of these spaces is worth what you think it's worth. Actually, each one of these spaces is worth a half. So when I go over to 4, what is this right here? 4.5. So where is 800 actually hitting? No, look at it again. It is not hitting at 4.5. If it was hitting at 4.5, it's on your book so that you should look there. It is a little bit bigger than 4.5, isn't it? So I would call it probably, it's not much bigger. It's not halfway. It's not halfway, so it's about 1/4 of the way. So I'd call that, no, I don't want one note. I would call that about 4.6 years. And it's an estimation, so if you're somewhere around 4.6, 4.65, maybe 4.7, that's close enough. Go ahead and do B for homework. You should be able to do that one. Now, notice this one right here. This one's a great one. This one says, I shouldn't circle that one. I'll do that with you. You're going to do a couple more problems. This says greater than 200,000. Look at the chart. Where is it greater than? Oh, let me talk about 200 real quick. Why is 200 a little tricky? What happens at 200? It hit 3 times. So guess how many answers you're going to have there? 3. So that's the little clue for that one. All right. Greater than 200. Well, what happens from here to here? What is all these values? All these values right here are greater than 200,000. Are you following me? How can I describe that? Because it's not, is it just 1x? Is it just 2x's that get me that? It's how many x's? It's actually infinite amount of x's, if you think about it. Think, if this, let's say, so right here it's a half, right? Does 0.555 work for me? Would it be greater than 200,000? Does 0.55555? Does 0.55532? Do you get where I'm going with this? There's an infinite amount of numbers between here and here, because we can talk decimals that go on forever. So There's an infinite amount of answers. I know that that's kind of mind-blowing in the beginning, but there's actually an infinite amount of answers that would get me here. How can I describe that if I say, hey, it's got to be bigger than this, but smaller than that? What can I use? What do we call those things? We called them domain when we were talking about everything x can be. But now I'm not talking about everything. We call those inequalities. We're saying, hey, it's got to be bigger than this value, but smaller than this. So if I wanted to describe this, what's the smallest x could be? About a half a year. But at about a half a year, how much profit have they made? 200. Is that greater than 200? Does this say greater than or equal to 200,000? No. It has to be what? So, would 0.5 work for what they asked me to use? So what do I do since they asked me it's got to be bigger? So I have to do without a what underneath it? No equal to sign. No line underneath there. So x has got to be bigger than 0.5, but it's got to be what? Less than. I would call that, yeah, 1.5. A little less than that, maybe 1.4. Somewhere in there.
So it has to be greater than half a year, like less than a year, 0.4.
For this part. But I have to continue on my graph. Continue following the graph. Continue following the graph. No, 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 not. Uh-oh. What happens here? All of this from here on up is what? Greater than 200,000. So it could be this one, or I'm going to let you guys do that for homework. Figure out the inequality that would describe that side over there. Is this making sense? So you're going to do C, D, and E. You're also going to do problem 2. You should be able to think about the end behavior of the function. You should be able to read these two people and figure out which one is correct. Let's talk about some other stuff that I wanted to discuss, just because this book doesn't do it. But let's look at this. Right here, would you describe this as bad debt? Like scary debt? Unknown? Like how is this debt right here different than this debt right here? Is it different to that person? To me it is. To me it's very different. What happens right here? What is the person doing? They're just starting. So when you start a business, what do you know? You're going to have to get it. Like when I start a business, I know going in, okay, I'm buying a building, I'm buying supplies, I'm buying all this stuff. So I'm investing, I'm getting some debt, but I eventually know with this debt, I'm eventually going to get it paid back and I'm going to start making money. So it's known debt. It's not scary. Does that make sense? I'm going in knowing about this debt. I probably planned for this. I knew how much it was going to cost. And right here, things are looking good. If you look, I have my investment. How much did it cost to start this business, by the way? How much did they go in debt to start this business? 200,000 is what they went in debt. Now, maybe they had some cash, so maybe they had their own money that they just spent on their own. But we know that they borrowed 200,000 to start this business. Are you with me? What happens over the first couple months? So that means they're making some profit and they're being able to pay off their debt, right? So even though they're in the negative, they're still what? They're gaining money, right? So this is good. This is good. She's looking, they're like, yeah, we're going, things are great. And then all of a sudden things take a turn for the worse. And right here, have they still made a profit?
Yeah.
Have they still made an overall profit? Yes. But things are not looking good because they're starting to what each month? They're starting to lose money, which means they're starting to spend more than they're making. Are you following me? Technically, overall, though, they're still positive. They've still made money. If they pretend the business got shut down, everything's gone, are they still okay right here? Yes. Right here, they get shut down. Is everything okay? They've lost some time, but they haven't lost any money. Right, Aiden? They haven't lost any money. But then all of a sudden, now, why is this debt down here? Why is this a lot different than this debt to me? Yeah, I mean, eventually they get down to losing a lot of money. That's just really scary. But I knew about this debt. I signed up for this debt. Things were going good, and then some kind of event happened to where I started losing a ton of money. And when I lose a ton of money, I've got to figure out what went wrong here. This I knew about. This debt was because I started the business. I'm okay with that. I accepted that debt. This debt, I have to figure out what's causing it. And I'm not okay with that debt because I was starting to make money and something changed in my business that started to cause me to lose money. And I've got to figure out what that is or else I'm going to be tanked. You following? The difference between these two debts. Yeah? Okay? Then some event happens that starts changing me and I start going up. Alright. Last thing we need to go over real quick is average rate of change. Average rate of change. What did you call back in the day when you had a line? And you wanted to know from here to here, how do you get there? What's that called? Slope. That is also, they're actually changing that name to rate of change. What's the problem with these guys right here, though? Does this thing have a slope? Does that thing have a slope? No. It's not a what? It's not a line. It's a curve. I can't have a slope on that. So here's what happens. Do you remember your slope formula? Y minus y over x minus x. Do you remember that thing?
Okay.
Most of your teachers put a little 2 and a little 1 here. Are you following me? I don't do that. I think that's silly. Do you know why they put that little, that's called a subscript. It has no mathematical value. Did you notice how this had a 2 here and this had a 2 here? Do you know what they're really just trying to tell you? These guys have to be in ordered pair together. Meaning if I give you 2, this x and this y. Are you following me? If you put this y first up here, this x has to go first there. If I put this y first here, then this x would have to go first there. It doesn't matter which one you put first. You can actually put either one of them first. But if I put this y first, this x has to go first. That's all those little super subscripts meant. That's all those little things we're trying to tell you. These guys have to be an ordered pair, and these guys have to be a ordered pair. If you do that, it doesn't matter which one you put first. Are you following me on that? Because the slope between here and here is the same as the slope between here and here. Doesn't matter which bubble or which x I put first, or y. No. As long as if I put this y first, that x has to go first also. You following me? So here we go. Here's what they do. they said here, and this is where we got to know, is this an ordered pair? Read what it says. You can determine the average rate of change in their profit for a time interval from 3.2 to 4.2. Is time a ordered pair? Time and profit are an ordered pair. Time is just the x values. This is saying from this x to this x. So that means you have an ordered pair of 3.2 comma something and 4.2 comma something. How are you supposed to figure out what that something is? You look at your graph. And when you look at it, you see 3.25 is somewhere around here. And if I look at that, it looks like it's at 600, because remember how I told you they go up by difference? This is 0. This is negative 200, 400, so that would be negative 600. You following me? So negative 600. And then if I look at my other one, 4.25, I go on my x to 4.25, that's right there. What's my y value? 0. Yes, sir. That's okay. We're not worried about it. Since they're both in 100,000, it would mean just putting a whole bunch of zeros behind it. I can leave it in terms like that. But thank you. Yes. So then, if you notice what they did is, do you see what does this really stand for? That's the y value when my x is 4.25. What's my y value? Do you see how that got replaced with a 0? And 3.25, the y value of that was negative 600. Are you following me? Notice, actually, if I would rather them write it like this for me, here's what I was trying to describe. Do you see how the 0 went first? So what would have to go first down there? The 4.25. 4.25 would have to go first, minus the 3.25. How do I know that that is correct? What are these two guys together? An ordered pair. What are these guys together? Could I have written it like this? Negative 600 minus 0. Yes, as long as what happened down here? 3.25 minus 4.25, and it would give me the same answer. Are you with me? Now, they show you the rest of that problem. They show you that when you figure that out and you subtract, really what happens when you subtract is this becomes a plus, and you get 600 over 1, which means your average rate is about 600,000 per year. Between this part right here, between here and here, you have an average range of, they make about 100,000 more each year. Are you with me? 600,000 more per year. Sorry. Yes? So what I want you to do for homework is all of 3. We talked about it. 4, which is very similar to it. And last one, look at 5.